Okay. Good morning, ladies and gentlemen. I hope you are all from Section 1 students. Are you Charia? Charia, are you from Section 1? Charia, can you hear me? Okay. He's not here, I think. Guys, I will take attendance in the last 5 minutes of each session, okay? Because this is compensation clause only for Section 1 students. It's not for everyone because last Monday, because of the public holiday, we could not have class, but we had class with other sections. And this our last class, okay? Because we have to cover 6.3 and 6.4. In our first session, we are going to talk about 6.3, that is about arc length, and 6.4, areas of surface of revolution. And 6.5 and 6.6, unfortunately, we didn't have enough time. I don't want to give have any more compensation class because next week is your final exam, so you need a lot of time to prepare for your final exams. That's why I decided to stop at 6.4, but it covers everything actually from chapter 5 and chapter 6, 1, 2, 3, 4, and also, as I told you, 2 questions from optimization problems. Okay. So now in this session, actually, we are going to talk about the more general curves. Okay. So in high school, you learn how to find the distance between 2 points. Actually, when we say distance, it is the shortest distance. Distance means that actually the line that connects, or set line that connects 2 points. But how about if you're talking about, let's say, the graph of the function over a closed curve, closed interval AB? Okay, so how can I find the length of this curve? So now we are going to develop a method or technique to find the length of a curve of the function, or the graph of the function over some interval AB. Okay, so suppose if we are talking about a function y is equal to f of x. Okay, y is equal to f of x, and y is equal to f of x. So this blue line is the graph of our function. So our task here is, how do we measure the length of this, curve? Okay, so if you're talking about some kind of thread or rope or kind of wire, right? You may think that I can just straighten this thing. After that, putting our measuring tape, we can measure this. Yeah, of course, but that's not a kind of knowledge. Okay, that is knowledge means that we have to consider the general case, right? And we have to develop some kind of formula so that, for example, let's say if you're writing some kind of game in computer, right? Actually, your car, let's say kind of parkour car, it is moving along this kind of bumpy path. Okay, just moving along this path. Okay, over the time is changing from A to B. Now the question is, what is the distance traveled by this particle, by this car? Okay, how do you find this one? So to answer this question, we have to know the length of this curve, which is given by the function y is equal to f of x. Again, actually, this idea is based on Pythagorean theorem. Pythagorean theorem, if you remember, if you are given in a right angle triangle, right? So a squared plus b squared is equal to c squared. Okay. So now I am going to choose some points, okay, maybe n points on this curve. And I'm just going to divide this into smaller pieces. Okay, let's just starting with A. That's a starting point, right? Let me just label this by P sub 0. And the second point, anywhere somewhere here, P1 and P2 and P3. And this one is P4 and P5 and P6 dot 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 Pn, right? So now we have n1, n plus 1 points on this curve. That means that now we have n pieces. We have just divided, right, or cut our actual, let's say, the kind of rope, right? We cut this into n pieces, right? So now I'm going to generate a formula for one of these pieces. Now suppose that here we have p sub k minus 1 and p sub k, right? So now I'm just connect this with this red lines. Okay, this is just straight path, all right? And I'm going to estimate the length of this blue curve by this straight path. All right, so this one, you see here, if I just zoom in only this small part, okay, you see here we have p sub k minus 1, and here we have p sub k, and I am going to estimate its length by this straight path. Let me just label this by lk. You see here, this lk, if I draw this vertical line and horizontal line, it forms a right angled triangle. And what is L sub k squared? L sub k squared is equal to delta yk squared, right? That's the length of this side. And delta xk squared is the length of this side. So now, using Pythagorean theorem, I can write this equation then. Taking square root of both sides, then this L sub k, that's a straight path from point k minus 1 to point k, right? It is equal to square root of delta x sub k squared plus delta y sub k squared. Now, if I just take out this, okay, taking out this, I will do this a bit later. And now, if I just sum up all of this length, right, that is L1, L2, L3, L4, L5, L6, dot, 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 we have LM. What are these? These are the straight path that's connecting two points, consecutive points, right? Consecutive points, that it gives us approximately the length of this curve. So the length of this curve is approximately equal to the sum of this straight path, right? From P sub 0 to P1, P1 to P2, P2 to P3, P3 to P4, and blah, blah, blah. So next thing is by using mean value theorem. If you remember, actually, mean value theorem, right? Mean value theorem says that if you're given a continuous function over the interval, our interval here is, suppose that this one is A and this one is B, right? Mean value theorem says that if you're given a continuous function over the closed or open interval, it doesn't matter here. That's the closed interval AB, then there exists some point in this interval. Let me just label this by C sub K. In our case, it's C, but now because of this indexes, C sub K, so that I can draw a tangent line that is parallel to, what is it? This second line. Okay, so that means that now I can just write this f prime of c sub k is equal to this p sub k, right? Is f of x sub k minus f of x sub k minus 1. That is delta yk over delta xk. All right, so now from here, instead of this delta yk, if I take this delta xk to the left-hand side, I can write this expression. Okay, that is mean value theorem. That's why, if you remember during that class, actually we stated that one of the most important theorem in calculus is, what is it? It is mean value theorem. So that's here we are using this. And after that, if I just substitute this expression into y sub k in our previous equation, then our this sum takes this form. So here we have sigma delta x sub k squared plus, what is delta yk? It is f prime of c sub k delta xk squared, right? And now delta x sub k squared, it is a common factor. We can just factor out, right, this delta x sub k and just keep this outside this root, because I know that this delta x sub k is a positive number, right? It's a positive number. Now we have this thing. So now what happens if I just improve our partitioning, right? That means that if n goes to infinity, then we expect that actually if this limit exists, then actually this, what is the limit of this sum, gives us the exact length of this curve, which is lying above this interval, right? So actually, that is just exactly the definition of our Riemann sum. Here we have a kind of function. Maybe it's not exactly Riemann sum. We don't have f of x, but now we can consider this one as f of x, right? Here we have delta x. So now it can be proved that actually this is exactly the definite integral of this expression. That is integral, our x is changing from a to b, right? 1 plus, I'm just changing this ck into x, and also this delta xk into dx. So that is the formula to calculate the length of a curve, which is given by the function y equals f of x over the closed interval ab. Now we can give this as a definition. If f prime is continuous on ab, so that means that f prime is continuous, means that actually we don't have any discontinuity. Otherwise, we cannot actually, somewhere is disconnected. We don't know what kind of discontinuity it is. So then the length, arc length of the curve y equals f of x from the point A, that is, coordinates are A and f of A, to the point B, whose coordinates are B. F of B is the value of the integral. That is, L is equal to definite integral from A to B, square root of 1 plus f prime of x squared and the dx. All right, that's it. Now, also, we will see that sometimes, we can also calculate this with respect to y, not only x. Example, find the length of the curve. Now, suppose that we are given this kind of curve. What kind of curve is it? I don't know. One of this x, right? When x equals 0, that's equal to -1. And when x equals 1, that's equal to, it is something. So maybe you are talking about some kind of curve, okay? When x equals 0, it is -1. So maybe let's say there's something like this. Okay, I don't know. So this one is -1, and this one is something that is x equals 1. So that's what is the length of this curve? Okay, some kind of like this. Anyway, even I don't need this one, but what I need to know here is it is continuous function over the interval, and also its derivative exists also this continuous. So actually in our expression, we have 1 plus f prime of x squared. And that's why we have to start first by differentiating our function. The first step, what is f prime of x? F prime of x is equal to, here we have 4 square root of 2 over 3 times this 3 over 2 comes to the front, right? Here we have 3 over 2 times x, 3 over 2 minus 1, that is 1 over 2, and -1 is equal to 0. Now, if you simplify this 3 is gone, 2 is gone. Here we have 2 square root of 2 times x to the power of 1 over 2. That's simply square root of x. So the next thing is I have to evaluate this expression, 1 plus f prime of x squared, right? So 1 plus, what is this f prime of x squared? That's equal to 2 squared, 4. Square root of 2 squared is 2. That is 8x. So that's it. The third step is now we can find the length of this curve over this interval. That is our x is changing from 0 to 1. So here we have 1 square root of 1 plus f prime of x squared. That is 1 plus 8x. And here we have dx. Here we have dx. Okay, now how we are going to evaluate this? We need to make some, what is this? Substitution. Here, suppose that y is equal to 8x plus 1. Now from here, then what is du? Du is equal to 8 dx, right? Or instead of this dx, I can write, what is it? Du, or du over 8. So here we have L is equal to, so now I can write here 1 over 8 times integral from 0 to 1, square root of 1 plus 8x. What is dx? Here we have 1 over 8 times 8 is 1. So here we have 8 dx. 8 dx is equal to u. And also I need to change integration limits. So 1x is equal to 0, u is equal to 1. So 1x is equal to 1, u is equal to 9, right? Substitution method. That's the first one. When x equals 0, there's here u is equal to 1. When x equals 1, it's the upper limit of this integral, right? So now I can rewrite this as 1 over 8, everything in terms of u. U is changing from 1 to 9. And here we have u to the power of 1 over 2. And 8 dx, that's equal to du. That's equal to 1 over u, 1 over 8. So 1 over 2 plus 1 is equal to 3 over 2. So here we have 2 over 3 times u to the power of 3 over 2, changing from 1 to 9. That's equal to 1 over 12, because 2 over 100, 2 over 24, that's 1 over 12. So when it is 9, square root of 9 is 3, 3 squared is 27, minus, when it is 1, it's just equal to 1. So the answer is 26 over 12 by 2, it is 13 over 6. So the length of the curve over this interval from 0 to 1 is 13 over 6. Another example, that one is just simple one, but sometimes, you should be really careful when you're simplifying the expression 1 plus f prime of x. If you just make one mistake, you know, you will be stuck in your integration calculation because the expression is under the square root. Anyway, again, first, let's calculate our f prime of x squared. What is f prime of x? F prime of x is equal to, so if you differentiate this, 3 comes to the front, 3 over 12 is 4. So here we have x squared over 4 minus this 1 over x, right? It is 1 over x squared. Okay. So now I have to evaluate the thing. It is 1 plus f prime of x squared. So that's equal to 1 plus our f prime of x is x squared over 4 minus 1 over x squared and squared. Okay, but my suggestion here is when you're expanding this, you should just do this without simplifying anything. Because my purpose here is I'll try to write the whole expression, this 1 plus f prime of x squared, as a square of something. Otherwise, we cannot take our expression out of the, what is this, square root. Otherwise, it causes a problem in calculating our integral. So that's equal to 1 plus, if you expand this, here we have x squared over 4 squared minus 2 times x squared over 4 times 1 over x squared plus 1 over x squared. Now, actually, if you look at this middle part, middle term carefully, okay? So that's equal to, what is it? X squared, they cancel each other. 2 over 1 over 4, that's equal to minus 1 over 2. All right. So now with this minus, what is minus? Actually, here we have 1 and 1 minus 1 over 2. If I just simplify this, only the sign changed, right? So I can just rewrite this as that's just equal to, because of this 1 plus the whole thing is plus 2 times x squared over 4 times 1 over x squared. So the whole thing is just equal to x squared over 4 plus 1 over x squared squared. A lot of students make a mistake here. They simplify this. After that, they actually find it so difficult to actually arrange this expression to change this into a perfect square. So our third step is we have to evaluate our integral. So then our integral, that length of this curve will be equal to integral from 1 to 4 square root of. What is the whole expression? This 1 plus f prime of x squared. So that's equal to x squared over 4 plus 1 over x squared and squared and dx. So over this interval, everything is positive. So I can just actually cancel the square root with the square, right? And so here we have integral from 1 to 4. Here we have 1 over 4 x squared plus x to the power of minus 2 and dx, which is equal to, the first one is 1 over 12 x cubed plus, actually, next one is, it will be minus, right? Because minus 2 plus 1 is negative 1 minus x to the power of minus 1. So our integration limits, it is from 1 to 4. That's equal to, if it is 4 cubed is 64. 64 is divided by 4. It is 16. So 16 over 3 minus 1 over 4. Minus, when it is 1, it is 1 over 12. 1 over 12 minus 1, which is equal to 16 over 3 minus 0.25 minus 1 over 12 and the plus 1. So that's equal to exactly, what is it? It is 6. Dealing with discontinuities in dy dx. Okay. So sometimes you will see that actually our function, when you're evaluating this, because it involves f prime, right? This f prime of x, it may not be defined at one of the endpoints, or maybe both. Like, for example, let's say x to the power of 1 over 3. If you differentiate this, right, its derivative is x to the power of minus 2 over 3. So if you actually, our curve is lying about the interval from 0 to, let's say, 3, right? As 0, it's not defined. We cannot calculate this. What should we do here? In this case, how do we solve this question? We can just interchange the roles of x and y, okay? Instead of differentiating y with respect to x, we can differentiate this x with respect to y. And here, we are not dividing this, what is the connecting lines with in a bit different way. We're just simply interchanging the roles of x and y. So at the time, if fg prime is continuous on CD, the length of the curve x equals gy from a is equal to, what is it, this point to this point will be, and this integral. Everything is the same, just we change the roles of x and y. Instead of x, write y. Instead of y, change x. And also this integration limits, right? It will be different because it's for y. Let's see one example for this case. Find the length of the curve y is equal to x over 2 to the power of 2 over 3 from x equals 0 to x equals 2, right? And see here in this case, if you differentiate this function, y prime is equal to 2 over 3 times, right? And here we have x over 2 to the power of 2 over 3 minus 1, that's minus 1 over 3, times, and differentiate this function, that's equal to 1 over 2. So this will be equal to 1 over 3 and cube. Actually, this will be, what is it? 2 over x to the power of 1 over 3, right? So now this function, because of x here is the denominator, right? It's not defined at x equals 0. So we cannot evaluate this at this point, right? It doesn't make sense. That's why we're going to actually use the previous method. I'm going to change the roles of, what is it, x and y. So we are going to solve this problem by changing x into y and y into x. So now if you raise both sides to the power of 3 over 2, so here we have y, that's the first step, to the power of 3 over 2 is equal to x over 2, right? Or from here, then what is x? X is equal to 2 times y to the power of 3 over 2. Now we don't have a problem with this. So actually also here immediately, when x is equal to 0, right? When x equals to 0, y is equal to, what is it? Is also 0. And when x is equal to 2, y is equal to 2 over 2 is 1, 1 to the power of 2 over 3, that is 1. So our y is changing that from 0 to 1. Okay. So next step is we need to find this expression, 1 plus f, not f. If I write f, you may get confused. Let's write it as, what is it? Dx and dy and squared. That's equal to 1 plus, what is actually dx dy squared? That's equal to 2 times 3 over 2 times y to the power of 3 over 2 minus 1. That's equal to 1 over 2. And here, squared, which is equal to 2 to cancel each other. 1 plus 3 squared, it is 9. And y to the power of 1 over 2 squared, that's equal to just y, right? So now we have just done similar thing here, but it was x. So now y is changing from 0 to 1. Square root of 9y plus 1, right? And here we have dy. So we have to evaluate or compute this integral. So that's equal to, by using substitution method or direct, I can do like this. So I can change this 1 over 9. So from 0 to 1. And here we have 9y plus 1 to the power of 1 over 2. Now here we have, I can change dy into 9y plus 1. Because differential 9y plus 1 is equal to 9 times dy. 1 over 9 times 9 is equal to just 1, right? So equals, so here we have something, right? U to the power of 1 over 2 and du here. So this integral is equal to 1 over 9 times 9y plus 1 to the power of 1 over 2 plus 1. It is 3 over 2. So in front here we have 2 over 3. It's changing from 0 to 1. Equals 2 over 27. When it is 1, right? When it is 1, that's equal to 9 times 1 is 9, plus 1 is 10. So that is 10 to the power of 3 over 2. minus 1 it is 0, it is just 1, that's equal to 1. So I can just do it like this because we can simplify this. In case in the exam, if I say that leave your answer correct to 2 3 decimal places, then accordingly, you can actually finalize your solution. Okay. One more thing. Okay, then after that, I will send you the attendance link. You need to write your name and surname and submit it quickly. Okay, and after that, we'll start our, after having some break, we will have our second session. The differential formula for arc length. The differential formula for arc length. Okay. So what is it about? Let me first talk about this. Okay, then we will see this example. Okay. So suppose that if y is equal to f of x, again, we are talking about this function, y is equal to f of x, right? So this f of x, and if f prime of f prime is continuous on AB, then by the fundamental theorem of calculus, right? What is it? So we are talking about, what is it? Here we have talking about, let's say, kind of curve. Okay. So this one is A, and this one is, let's say, it is B. So that's our y-axis. So that is the graph of our function y is equal to f of x, right? Now we are talking about the length of this arc, okay? So that s of x, then this s of x will be equal to what? So here we have integral from a to x. So here we have 1 plus f prime of, I have already used x here, that's why I need to write here f of t. F of t squared, and what is it, the right? Actually, this s of x, it depends on what is it, this value. So I'm not talking about this b here, I'm talking about some point. Okay, see, and I choose some x here. We are talking about only this part, we are talking about only this part, right? We are talking about only this part. If x is equal to b at the time, so s of b, right, we'll have the length of this arc from a to b, square root of 1 plus f prime of x squared, and dx, that's the length of this. And how about this? I choose some point x, right? Now x is a variable. It can be this point, or it can be any point on this interval, right? Or any point on the interval ab. Okay. So now this, by using fundamental theorem calculus. Now if I just differentiate both sides with respect to x, what happens here? Let me just write here. Here we have dx and the dx, right? Fundamental theorem of calculus says that if you're given a function, if you integrate this over the interval or a to x, right, and differentiate this, it gives us our original function back. So what is our original function? Here it is this thing, right? So that is equal to square root of 1 plus f prime of x, and here we have squared. That is squared, right, is equal to this. Or simply, I can just write it as 1 plus dy and the dx, right, f prime of x, that's equal to that thing. Okay. Then the differential of arc length. So the differential arc length means that just the small part, right? What is it? Then this differential arc length, this ds, means that the differential of this arc length, this s is the arc length, right? It will take this form. I'm just taking this dx to the right-hand side. That's equal to 1 plus dy over dx. And here we have squared. And on the right-hand side, also I have dx, right? A useful way to remember equal to 6 is to write this as sometimes, this dx squared and dx, they cancel each other. Sometimes also you can just write it as, what is it? Here we have dx squared plus dy squared. Okay, and dx, they cancel each other. But actually that is the kind of, what is the difference of arc length. Okay. So that means that sometimes, maybe right now we are not going to use this much, but in the future, especially for students who are going to take calculus 2 or calculus 3, at the time we are going to use this concept, okay? Because I need to know, for example, travel from A to X, right? How can I write this differential of this arc? And especially when we study about line integral. Anyway, let me just show you one example and finish this session. Find the arc length function. Okay, arc length function for the curve taking A as a starting point. So taking A as a starting point means that here we have x-axis, this one is y-axis, 1 and 13 over 2, it is something here. Okay, let's say there's something here. So this one is 1 and this one is 13 over 2. Starting from here, right, our curve is something like this maybe. Let's say something like this. So now starting from here to any point, right? Any point, let's say this point is, it is x, this one is, it is x, right? What will be the arc length function for this? So from here, we know that arc length function, that is 1 plus f prime of x squared is equal to, what is it? So that's equal to 1 plus square root of this one. We have just seen this one, that's equal to x squared over 4 minus 1 over x squared, right? So that thing, that thing is equal to, if you remember, we had just done this, that's equal to x squared over 4 plus 1 over x squared and the squared. So now we need to find, what is it? And the question is saying that what is the arc length function? We have to find this arc length function. So this arc length function would be, that is as of x, right, is equal to integral from 1 to x square root of 1 plus f prime of t squared. That's a function of x, and here we have dt. So which is equal to integral from 1 to x. So this 1 plus f prime of t squared, right, that's equal to x squared over 4. Actually here, there should be t squared over 4, t squared over 4 minus plus, right? Plus, let me just write here as t to the power of -2, and here we have dt. So which is equal to, now if you integrate this, the first part is t cubed over 12, right? Minus t to the power of -1. From, what is it, from 1 to x. When it is x, here we have x cubed over 12 minus 1 over x minus, when it is 1, this one is 1, when it is 1, and here we have 1 over 12 minus 1. Okay, so which is equal to x cubed over 12 minus 1 over x. 1 over 12 minus 1, that is minus 11 over 12. So that's plus 11 over 12, right? So now what does it mean? It means that now we are talking about kind of particle, right? Let's say the starting point is 1 and 13 over 2. Let me just label this by A, right? So suppose that we want to find the length of, let's say, the distance traveled by some particle, which stops at here. Let's say that starting point is P, okay? Another particle, let's say it stops here. Let's say this Q. And another point, it stops actually here is R, right? So for each particle's distance, whether travel distance, we don't have to actually go through these steps. Now, once if I get this formula, this S of X, right, I know this is equal to this, right? In this case, for example, in P, let's say our stopping point, right, or terminal point, or end point, whatever it is, stopping point, that is equal to 5. Just substitute 5 here using this formula, I can find the distance traveled by this particle. Okay, so Q, it stops at 7, right? Just substitute 7 into this expression. I can find the distance traveled by this particle over this time interval, right? And also R, for example, it stops at when x equals 10, and substitute 10 here. We don't have to go through this procedure. Now, everybody, I'm going to drop the link. Okay, I will give you 5 minutes to write your name and surname. All right. And after that, we have 20 students. I will finish the class. All right.